Hello everyone and welcome back to another Classic Arcade Repair. Today I have on the bench a BattleZone set by Atari, and I also have with this repair the AR. I'm going to go over the AR power supply. First thing I did when I got this is, as I usually do, I went through the software. This ROM was bad, which will cause all kind of problems because this is the 8 bits that come out of this guy are what address, I believe, these guys. I'd have to look at that again, but I think that's how that is. I'm not sure. We had one bad ROM here. The rest of them verified okay. Yeah, so I am going to eliminate, because all these sockets are problematic, so I am going to eliminate all this. I'm going to replace these two sockets. I'm going to replace this socket, and I'm going to remove this socket right here, and in its place I'm going to put this single ROM PCB right here, and it's going to have all of the ROM code. I've already programmed this 256. It's a 27C256, and it has all of this code on it. So that will take place of all of these. And I have programmed a new chip for right here. So that is good to go. So that's the first thing I'm going to do. I'm going to replace this guy, these two, and remove this one. Is I'm going to solder this directly into here. And then all we have to do is run some address bits over. This is a board that I designed. It's a single ROM PCB that takes place of all of this. It works for basically any Atari game with multiple banks of ROMs. So we're going to use it right here. And this is one of the PCBs that's on my Patreon page, if you're interested. All right, so I'm going to get to it. Start doing some maintenance, and we're going to have a lot of maintenance to do over here. I don't know what's going on. There's a socket that's been replaced here. I believe all of these are untouched. Yeah. Broken solder joints galore on here. And the board itself. I don't know if it's getting that really good. I'm going to take a closer look under the... I think those are unsoldered. They are. They're unsoldered. They've never been reflowed, and they're just terrible looking. So I'm going to go ahead and take a closer look at that. Other than that, the board's pretty clean looking. Not bad. All right. So let me get to it. I'll be back. Okay, I've got my sockets removed. That one there, those two, that one, those two, the CPU, and I just got done resoldering this connector, and it took solder really well, and it really stuck to the pins, so it was a good soldering. You can tell when these need to be replaced and new headers put in when solder will not stick to them. If you see how these have a nice fillet, it's called a fillet, like a cone. You can tell where it really soldered good. That one needs to be redone a little bit, just touched up, but for the most part, these are all nice shiny cones that are really well soldered. It needs to be cleaned up. If you're soldering these and it just blobs up and won't stick to the pin or whatever, then you know you need to replace these. Then go ahead and remove the solder, remove the pins, and replace the headers themselves, because they just won't solder anymore. I've removed the regulators, voltage regulators for the analog out section. Yeah, so I'll go ahead, finish doing what I'm doing here. This board could actually use a good washing. I think I'll go wash this board before I populate anything else into it. I'm going to go ahead and clean this up and resolder that one that looked like it kind of bubbled up right there. And that one looked like it just bubbled up. And bubbling, when solder bubbles up like that, it's a product of old oxidized solder and new solder mixing together. So you just gotta might even want to remove that and resolder it. But yeah, so I'll go ahead and do that. Clean this thing up. I'm gonna go wash this. I've removed all of these. These are all removed. That one's good. Good dual wipe socket there. Someone replaced. So I'm gonna wash these boards, both of them. I'll solder this one. I'll make sure this is soldered really good. And then clean up my flux and then go wash these things. Okay, yeah, this auxiliary board, you can see where this solder really took really good. And you got nice shiny fillets or shiny silver cones. If yours, I need to clean this flux, it's kind of a fluxy mess, but if yours doesn't do that, if it just wants to blob and not stick, then you need to replace your headers. Okay. Okay, and here is the refurbed auxiliary board. New sockets, new chip here, and all the work has been cleaned up. And these nicely cleaned. So this board is good to go. Now I am going to go wash that board and get it cleaned up and then populate it and see where we're at. Okay, and this is the best way to solder your leads into your little boards, is to have a breadboard that you can use, right? And we're going to cut them down to size. Cut them down to size. Yeah, I could just count, but what's the fun in that? Okay. And put these babies in here like so. And then pop it into your board like so. And that's when you solder it. So we'll turn our iron back on. Oops. You know, that might be better to solder. You know what I'm going to do is first I'm going to get my 28 pin socket. I think it'd be better to solder that in first. maybe. We'll try it. Let's solder the 28 pin socket on here first, and then will that just sit right over this? And no, that'll be hard to solder that, so scratch that idea. Okay. I'm going to be in your way, because I gotta be. Solder one, hold it, let it settle, and then solder this end, and then solder the rest of them. Let it dwell for a second on the ground pad. And this one over here, this is the voltage, so let it dwell just a touch longer. And there you go. That baby's soldered on there. And that's how you get nice, perfect solder on your boards like this. So now I'll go ahead and move this, and we'll solder the 28 pin socket on. And it's kind of the same thing. You want to do the side that rocks the most, and it's actually ground, so I'm gonna solder it good, and I'm gonna let it dwell and kind of hold it down a little bit. So you want that to dwell pretty good on that ground so it really solders well, you know. And the same thing, this is 5 volts. You just leave it on there a little bit longer than you normally would. There we go. Now you can solder as normal. And I'm going to come in like this because it's just going to be easier for me. Try not to melt anything. And doing this kind of a job right here is a good time to have one of these angled bent tips. You can get down into there. Okay. Once you get that side, this side's quite easier. Okay, so that baby is on there. Now, one thing about this particular board is I've designed this to also work with 28 series chips. And 28 series chips are a little bit different in how they work you actually want a little bit of a delay on the enable line until the not the enable line, but the the enable line. You want a little bit of a delay on the enable line so that the 5 volts has time to come up on the right pin. So I've got to where you can put a 0.4 in here, and it'll create about 100 nanosecond delay or whatever. It just goes through a bunch of the gates on the chip so that it won't write erroneous data to that chip. You don't have to worry about that on the 27 series because it doesn't use a write enable. It uses a program voltage. The 28 series is different. It needs a little bit of a delay on that enable. So that's what this chip's for. What we're going to do is I'm just going to put a jumper from ground to pin 4, and that will connect the enable right to ground. So I'll do that and I'll be back. Okay, I'm going through putting in sockets. I've got these 2 sockets, this one in. I got the board cleaned. It's really nice and clean. But I went to, because I'm going to hard solder this into the board. I don't want it messing with the socket. So I was going to put this in here and it covers this RAM. And I don't like that. So I'm removing this socket. Because it doesn't matter which socket it's in. So I'm going to remove this one right here, and it's going to sit right here like this, so that I don't cover up any of these RAM. So, alright, I'll be back. I'm going to go ahead and remove these pins, clean up, and then that's going to go in right here. Then we just have to pick these 4 address bits and run to it. And we'll be good to go. Alright. So we have our program all into here. You can see I have the address bits picked. You just got to find out where they're at. 11 and 12 come to right here, which is really convenient. But 13 and 14 I had to pick right here. All they do is go to this chip for decoding right there. That's all those do. And yeah, so that's that. I'll put the vector ROMs. Now the vector ROMs have a different decoding scheme, so you can't include them in this. What you could do is you could put both of them into one 4K ROM. And just, you'd have to, if the hardware accesses the ROM, which I think they do, you would have to run both of the selects into an AND gate. So it'd be another board like this, but it'd have an AND gate here, and if either one of the inputs go low, the output will go low and enable the chip. You might be able to just ground the output because it might constantly be selecting from one of the EEPROMs. And if you put the 2 files into one ROM, then you could just ground the enable. I'd need to look into that more. But this will work for this. So I will go ahead and get a better. Yeah, the wires coming up through here. Those are those addresses. That will nicely eliminate. And this I did revision 2 BattleZone E1 file. So yeah, I'll go ahead and put these chips in here, and I think first thing I'm going to do is put the fluke on this and make sure that this is indeed working correctly. Plus I can check these RAMs, and then I can check all of this RAM too. So I think that's where I'll start. And before I did that, I went ahead and put my new regulators in. So I got my new -15, 5, and +15. Brand new. Good to go. Looking good. Okay. Go ahead and put these ROMs in. And we'll do some fluke testing. Okay, I got the fluke rolling. I've tested this bank of RAM 2000 to 2FFF, and it's fine. I get to these two guys, which are the CPU's working RAM at 0 to 3FF, and they're both bad. If I remove them, I have them jumped. And I loop this. Let me do a RAM at 0 to 3FF. Bad. I'll loop it. It says FF, which means both chips are completely bad. So if I jump one of them, I jump that one, I get 0F, which means the upper 4 bits are now good. And then if I jump the second one, it tells me that it's all good. Now if I rerun that, yeah, both of these RAMs are no good. There you go. Yeah, so we got 2 bad RAMs. Those need to be replaced for sure. Just put my good ones over here. Those will go in the board eventually. Now I'm going to check the ROM. What I'm going to do is I'm just going to run the fluke because I don't have the signatures out here with me. So what I'm going to do is I'm going to run the signature. I'm going to document what it tells me the signature is. And then I'm going to go in on ROM ident inside the house and verify and make sure that the fluke sigs are what it actually tells me. So I'll be back once I do that. Okay, that was a complete success. They all checked out. And I went ahead and looked at the memory map and I got the dip switch read. Because I like to, when I got the fluke out, I like to, if I can, if I know the option switch address, I like to read it. And right now, they're OA00 and OC00. This one's OA00, and this one is OC00. And right now, I'm looping a read on this one, and it's telling me 11, and that's because it is 11. This one should be FF. Let's turn all of these off. So now it's FF. Now let's turn them all on. Now it's 00. Okay. 1. It was at 1-1. That's good. So that one's good. Now let's go ahead and read at 0C. 00 and loop that. It's at FF right now. Let's turn them all on, which puts them all to ground. Now we got 00 and back to FF. That's it. Those are good. So our CPU is reading options fine. So that decoding and that circuitry all works. So all I have to do is replace these 2 RAMs. These are all good. And my ROM is all good. And then, yeah, that's such a nice tool to have, this fluke, I tell you. It's amazing. Anyway, yep, there you go. So we'll go ahead and replace those 2 RAM. Okay, moment of truth time. We are all hooked up. New ROM here. These are all untested. These are good. Don't know about any of this. Got the RAMs replaced. Socket, the CPU back in. I don't know if the CPU is any good, to be honest. But I've got the little scope I've got this scope hooked up for XY. And we're going to go ahead and fire it up and see what happens. We're on. And it looks like we're getting nothing. A great big nothing. Okay. Huh. Nothing. Let's try test. Alright, so it does one high tone and then a low tone right after that. Strange. Okay, well, I'll have to look at the manual and see what that says. Yeah. All right. Let me do a little research and I'll be back. Well, I replaced the CPU. And I now have BattleZone rolling. But something is not right. BattleZone. Remember when my RAM were bad until I jumped RAM over it? Something's wrong with the decoding and it's flaky. Something's flaky with the decoding, and when I jump a chip over it, it settles it down. So there's actually a decoding error on here. So the CPU is not the problem. This CPU is fine. It's in the decoding, and the RAMs were actually probably fine. So I'll have to look into that and see. I'm going to have to pull the schematic and find out what is enabling these guys. That's what it is. It's the enabling to these. And I'm sure that these probably share a data path back. It's got to be something. It's got to be one like a control signal, because you jump over it and it straightens right out. So yeah, and it doesn't matter. It does matter. It's this one right here if you do this one. Okay, now it's not. It doesn't seem to want to work now. There it is. Came back. Remove it, goes away. Try this one. This one isn't so much. But this one here, yeah, there it was. I don't know. It's just, it's goofy with it's involved with these RAMs. So I'm gonna have to take a look at those signals and the decoding for these guys. Okay, unfortunately, I do believe I know what's happening. And if I grab the notepad, I will write down, I'll go through what I believe is happening here. Okay, my guy here is enabled from the addresses 000 through 7FFF because it's always enabled, okay? What we have here is this range is 0 to 3FF. That's this range. So what is going on is when this is trying to read from these, it's expecting these ranges from 0 to 3FF on this to be tri-stated and not influencing the RAM. And what I have here is this is programmed from 0 to 4 FFF is programmed with FF. Because it's not, the ROM starts at 5,000. It goes 5,000 to 7FF. So I programmed from 0 to 4 FFF with FF. Well, when this is trying to read from 0 to 3FF, this is conflicting with this. This is trying to spit out FF. At the same time, it should be tri-stated. It should be disconnected, not influencing high. That's the problem. So what I really needed to do, what I need to do is put some address decoding into this. And I could use a, what I'm going to have to do is run all of the ROM selects to an AND gate. These all have to go into an AND, and then the output, when any one of these goes low, the output will go low. So if any of these is trying to be activated, the output will go low, and I need to connect that output to the chip select. That's what I need to do. This cannot be the way that I have it like this, because I believe it's conflicting with this RAM, and that's why it won't run, unfortunately. There's really no way around that, unless, okay, ROM, that's ROM 0 through ROM, and that's ROM 0, and this 0, PMEM high, PMEM low. There's two signals right there. Actually, I believe that these two signals right here, P memory high, P memory low, those two signals right there I could run through a AND gate, and the output of that is what should enable my ROM. I'm going to look at this a little bit more off camera and just verify that, but I think that those two signals right there are the memory signals, ROM signals. So I think if I just picked those two signals, ran them through an AND gate, we'd be good to go. So let me look into that. I'm going to verify that, and I'll be back. Okay, yeah, that's exactly what I'm going to do, is these two guys right here, those two signals, when this one goes low, it activates this decoder, and when that activates, something's going low here, and those are all ROM. So that one, when it goes low, it automatically activates ROM. This one, when it goes low, it automatically activates, when it goes low, this 32 will either go low based on address bit 11. So one of these will go low based on address bit 11. I don't care about address bit 11. All I care about is this signal. So these two together through an AND gate, the output will go low no matter what and activate my ROM. So I'm going to find where a good place to pick these two signals. I'm going to modify this. I pulled the resistor, the 0 ohm resistor. I pulled that, and I'm going to place the 08 right here, and I'm just going to run wires over to it. I'm going to get my little Dremel out, and I'm going to separate all of these connecting wires. Actually, this side I don't care about. I'm just going to do it right here on this top 3 pins. And I know there's nothing on the back except for pin 4. Pin 4 on the back side of this runs to the enable. So what I'm going to do is I'm going to run the inputs to 1 and 2, and then I'm going to jump pin 3 to pin 4, because that'll be my output going to this guy to enable it. But I have to get the Dremel out. I have to separate these little interconnecting traces. So I'll do that. Put a 08 in here, run a couple of wires, and should work perfectly after that. I'll just have to make a little modification to this. It'll actually... This will work if the RAM data is separate. If the RAM data path back to the CPU is separate, this will work, which I don't believe on Atari it ever is. So this decoding will have to always be on here. Yeah, see, if these weren't shared, if this data bus wasn't shared with the ROM, if it wasn't shared, then I wouldn't have to worry about this. But I believe that's what's going on, is this is, when it should be tri-stated, it's trying to drive that high. If this is trying to put a low onto the bus, this is trying to put a 1 onto the bus, and they're conflicting with each other. So this needs to go tri-state. So we're going to do that. I'm going to modify this. There'll be 2 more wires run out, and I'll make it nice and neat. I'll try to find a good place to pick them. And then, yeah. So let me do that. Okay, so I got the fluke back out. I have removed all of the ROMs and sockets. I removed my thing here that I had in there. Yeah. And if I run this test now it's fine. That's all it was, is that shared bus, that shared data bus. Just you need to have tri-stated. It has to be tri-stated. You know, it's flaky. You can get it to work by popping RAMs over. You know, you can get the board to work, but it's just flaky, and it's because it was because of that little board that I had in here. The ROMs were driving the signal high instead of being tri-stated, and it was fighting with the RAM. That's what was going on. So yeah, I would have to redesign that board and put a I just decided to remove it and put sockets and go with the original chips, because I need to redesign that board. And I need to redesign it with a logic circuit, a 30 or something like that, a chip that has more inputs. I got 6, like on this board right here, there are 6 ROMs, so there's 6 signals activating 6 ROMs. So I would have to send each one of those signals to an AND gate, and then that, if any one of those went low, it would send the output of the AND gate low, which would activate my ROM. That's what I have to do. I have to just redesign it and put that little piece of circuitry on it. Not a big deal, but I don't want to run any more wires around on this. So I just went ahead and removed it. And I'll put sockets in. And we'll put the ROMs in. I think I have to reprogram 1 ROM, maybe. I don't remember. And then it'll be good to go. But yeah, this is fine now. Once I got that ROM off of the off of there, it's fine. Okay. All right, and that's that. New sockets. And I need to clean right there a little bit better. But yeah, they're in. I'm going to go ahead and scrub this one more time and then populate it up and see what happens. Okay, I'm getting it populated, and this is the one that was bad. It's a 412, and that's the one that's no good. And I do have some just ROMs that I've saved, and I've got BattleZone ROMs, and I have a 412 in here, so I'm going to grab it out of here and pop it in, and we'll fire it up. Okay, I replaced that chip. They're all in the right way. I got the little scope fired up. Yeah. Okay. Now I'm going to have to go back through with the fluke again and see if I can see if these ROMs are right. Man, jeez, criminy. All right, I'll be back. We got issues. Okay, I had to get the fluke back out because I put this back together, turned it on, and it still wasn't working. So I got the fluke back out, and I wanted to test these ROMs one more time in circuit, and the RAM and everything else. The good news is the RAM is now fine after removing this guy. After removing that, then we're good to go. Okay. Now if I do a ROM on 78 to 7, that is supposed to be 4 CCE. That's this guy right here. 4 CCE. That is coming up with an error, and it's giving me D107, so that ROM is no good. It's this one right here. So that one's got to go. And I think I have one of those in my stash of BattleZone. I got a stash of old BattleZone ROMs. Here's one that says miscellaneous. It says miscellaneous missile command in BattleZone. I got another one. Here's BattleZone. That's the ROM right there, N1. That's the one I need. So go ahead, pop one of those in there and see what we get. Okay, I popped that one in there, and this one is the bad one that I've got marked with a green dot, so you just never know. These things might dump good in a programmer, but they're just not good. It's strange. I don't know. It's weird. So that's another bad ROM, and I popped this one in there, and if we do our test, it comes back good. So now we've got a good set of ROMs. Our RAM is now readable. So we should be good. Okay, excellent. So now we can go ahead and put it back together, put the fluke up, and give it a shot. Okay, I had removed the fluke, and it still didn't work. So I was like, all right, I'll put the fluke back on it and just make sure that I can get to the vector RAM, which I could earlier, but now it's not working. And long story short, I turned the scope on and I probed around the control on this, and pin 10 is floating, which is the right signal for the RAM. And it's floating, and it comes from this guy right here, this L2 chip, which is a 32, has a floating output on pin 11. So that needs to be replaced. So let me go ahead and replace that, and I'll be back. Okay, we're back. This is that 32 that was bad. I went ahead and replaced the chip next to it because this was working before, and I soldered to this chip when I soldered leads up to this thing. And I soldered to this chip as well, so I just went ahead and replaced both of them since this one actually went bad after soldering to it. So, yeah. Go ahead and just replace both of them. And I've got it hooked up. And let's go ahead and turn it on, and hopefully it works. Oh. That is out of socket. Let me fix that. Let me set this down. I just happened to notice that. Turn it off. I'm going to remove that chip and fix that pin. That's the reset pin. Pretty sure that probably needs to be in circuit. Okay, there, that's better. Let's try that again. Oh my goodness, it's doing this again. God, this thing. How annoying. Well, I don't know. I wonder what that means. I guess I got to get the fluke back out and try testing this stuff again. See if I can read this stuff now. I don't know. We're going to have to... We'll see. Fluke time once again. Okay, it turned out I had a bad 32 that I put in the board. I put a different one in, and now I'm just getting done testing everything that the fluke can test, except for the I/O, which we already did that. But I'll do it. See, they're okay. This whole bank is okay. I tested all the ROMs again. They're all good. And I tested this RAM again. It's all good. Now I'll read from 0A00. Remember, it was 11. That's this guy. 11. And then this one will be actually not FF. It should read 1F. No. E1 or E0. It should read E0 at A or 0C, was it? 0A00. I don't remember what the other one was. F7, that might be it. This is on, so that is a 1 and those are zeros. So that would be F7. F7, that's correct. F7. Very good. So yeah, if we loop that and I go ahead and do this, now it'll be FF. Yeah. Which is what I wanted at, so. Alright, yeah, it's all good. All the fluke stuff now is good. So let's take the fluke off, put the CPU back in it, and this thing should work. If it doesn't work now, it's not nothing to do with the CPU and the RAM and stuff. It's actually logic. So we can actually move forward now. Goodness. Okay, I left the fluke here just in case. I put the CPU in it and I turned it on. And we have BattleZone. Very good. I want to go ahead and turn this off, and I want to put all of this away, and then I'm going to plug in the small vector monitor and make sure that it's coming up good over there. Okay. We got it rolling here, and we got it rolling here. And it looks right. Looks good. There you go. And I'm pretty sure that the sounds are all good, but I'll have to test that. Tomorrow, I'm going to finish this one up tomorrow. It's kind of late, and I have to let this run for at least 3 hours as standard practice. So I'm not going to wait around for that tonight. So I'll come back tomorrow. We'll test gameplay stuff and sounds and all that, and I'll let this thing run. So be back tomorrow. All right. Good morning. We're back. And it ate at me all night, realizing that when I soldered to this chip to send that signal over to this guy to be processed, remember how that killed that chip? Well, it was really bothering me. I know this will work. So I decided to wire it back up. Hook it back up. Wire it back up. Unfortunately, there is no good place to pick these signals other than the chips themselves. There's no via going through the board that you can solder to there. So remember, I used my Dremel to cut the little traces on here that was jumping things together. And I brought those two signals over to this guy, and then the output of that is what's enabling the ROM. That allows the data outputs to be tri-stated when it's not being selected. I've removed all of the ROMs, the old ROMs. This one I've got in a socket in the socket. I don't like that. This should be soldered right to the board. But yeah, this does work. Works perfect. Yeah. And you could do the same thing and eliminate these two guys and use a 2732, and you would just have to take the two. It'd be good to make a little board like this, and yeah, maybe I'll do that. Maybe I'll design a little board that goes into the, you could solder it in right here, and it would have an AND gate on it. It would have a 08, and you would have to take the two ROM signals for these two chips and run them through the inputs of the AND gate, and the output would be the enable for the ROM. So yeah, and the reason why you can't include these files in this file because these do not have a shared data bus. So yeah, I don't know. There's probably a way that you could actually include all of this on one and do some fancy decoding, but I don't want to do that. I would rather have the program on one and the vector program on another, separate. So yeah, I think what I want to do with this is remove this socket and solder this thing directly into the board. I might even remove my other sockets to keep my sockets, I don't know. Yeah, but this is much better having one ROM like this, because these things right here have an extremely high failure rate. These guys. Very high failure rate on these parts. So those things, if you can replace those, you probably should. Even if it's just using EPROMs instead of these masked ROMs, use EPROMs. But yeah, you got to run a few wires to do this, you know, but it's cool. You'll never have to worry about ROMs again. It's one program ROM. Yeah. So I think I will go ahead and I really want to get my desoldering gun out and remove. I would like to salvage my sockets. So I think I will do that. Remove my sockets. This thing will get soldered right into the board. And that'll be a permanent solution. And then I'll probably route these wires a little bit better, how I had them the other day. Route them under some and through some stuff. So let's tidy this up. One more time, I just want to go over what I did here with this ROM, the single ROM combining deal. The 256 has 14 address bits, so I picked address bits 11 through 14 from the board and ran them over to my little daughter board, my little satellite board that holds that ROM. And then for the decoding, you can see the original has all of these ROM signals right here. So you come up to decoding and find those, and they are right here. ROM. And you can see that most of them are made off of this guy. Let me get something to point with. Yeah. Okay. You see that most of these are made off of this 139 here, which is enabled by this signal. And that's program memory high. And then you have program memory low. That's the only two signals that we need. Because this isn't going to do anything unless this is enabled. So this enabling enables program memory. And the same with this one. If this isn't enabled, that's going to be a 1. So this will be 1 no matter what, because this is an OR gate. So this has to be a 0 for this to be activated. And it's just a matter of address bit 11 determines which one of these goes low. So these two signals are the signals that I picked on the ROMs, where I soldered to those ROMs, program memory high, program memory low. Those two signals go through an AND gate, so if either one of those is low, the output of the AND gate will be low, and that enables my single ROM. That's the explanation of that. Before, how I had it, you know, my thought process before was, all right, well, this program memory right here, or RAM, is 0 to 3FF, and it is shared data bus with this. This doesn't start until the address 5000. So in the ROM, in my single ROM, from address 0 to 4FFF, I programmed FF into the chip. Well, the problem with that is, see, these are pulled high right here. These data lines are pulled high so that when they are tri-stated, they'll be high. But being that they're pulled high through a resistor, you can still pull them low. You can drive them low. And that's what the RAM will do. When the RAM is activated, it can drive that bus low through the resistor because of the resistor. Well, what I had here was when the CPU was addressing address 0000 to read RAM, it was dumping onto the bus FF from address 0000 on here, and that is not through a resistor. So it was fighting with the RAM. The RAM and the ROM were fighting each other. And remember, I could jump RAM over the existing RAM and it would work, because it would have enough behind it to overcome the influence that the ROM had on the bus. So the idea of picking these two signals and running them through an AND gate to create an enable for the ROM is so that these outputs are tri-stated instead of driving FF onto the bus. This tri-state is not the same as a line-driven FF, you know, because this has resistors that can be, these are pulled high through resistors, so the bus can be driven low. So yeah, these were just fighting each other. Well, that's what that was all about. You know, the gun's heated up. I'm going to go ahead and remove some of these sockets and fix this thing up. Okay, got my sockets removed nicely. I removed this one and soldered this directly in. And I rerouted my wiring to be nice and out of the way and not just dangling around. I cut these back to fresh wire and redid it, resoldered to the chips. These are in place well. Yeah, this thing's looking really good now, so we'll go ahead. I'm going to put a window covering over this and fire it up. And here's the back of that board with that daughter board soldered into the board. Absolutely zero damage to the board. And looks really nice. Okay, I'm going to plug it in and make sure it still works. No reason why it wouldn't. Yeah, hooked back up. Fired up. BattleZone. So the only thing left to do is play it. Yeah. Nice. Very nice. That eliminates those high failure rate masked ROM files, ROM chips. Those things are terrible. So here we go. Good to go. Well, let's put the camera on the tripod and play a game. Okay. 2 coins, 1 play. I'll have to look that up and change that. But we'll put 2 coins in it. And start. Alright, gotta play another one. That was too quick. I got my butt kicked. Big time. There we go. Oh no. Get over here. Turn the lights back on. Yeah, I can't really play it too good because I have all of the controls hooked up to an Atari joystick. So left, up, and down is like, I don't even know how I've got it wired, but you have to hold it like a Cubert joystick. And you can go this direction, that direction, and so it's not ideal. I can't make sharp turns because I can't go down on this one and up on the right one at the same time because of how it's wired. I got all four control inputs on one stick instead of two. That's what I'm trying to say. So I can test all the controls, I just can't make good controls, if that makes sense. So yeah, this one's done. I did a lot of work on this one, but I did a lot of unnecessary work, like all the sockets I put in. I took my sockets back out and I kept them. So yeah. This is soldered directly into the board, so there's never going to be any connection issues. I replaced these 4 sockets. I replaced this chip. Remember, this was bad. I resoldered these nicely. I replaced this socket and I replaced these 2 sockets. I replaced these regulators up here. I replaced these 2 chips. I replaced both the RAMs, even though the RAMs were not bad. Remember, they were not bad. It was just how I had this thing wired with this. How I had the circuit working wouldn't work because the outputs of this were not tri-stated. So now they are. Now it works. Yeah. I believe one of the actual program ROMs was bad. 2 of them. 2 of the program ROMs on this board were bad, but we've eliminated that with this. Yeah, so a lot of maintenance and a few bad parts. So that's it. This is nice. I like this a lot. But I will have to redesign this, or maybe I don't know. I'd like to look at, I think I will have to redesign this to make, this has to have this little piece of decoding on board. But it's good. It works fine. Works perfect. So I'm just going to go ahead and let this one sit here and run for a few hours today. That's going to do it. Big shout out to all the Patreon members and channel members that help me keep this going. I think I charge a pretty fair rate, and I'm able to do that because of the support I get in the channel and through Patreon to keep this all rolling. Because this stuff is important to keep this old history rolling. So yeah, thank you to everybody. We will see you all on the next Classic Arcade Repair. Bye for now.